F is a continuous function, so this function we've drawn in red is f, and it's defined on the interval from -4 to 3. So we see here that the end bounds are -4 and +3. And the graph consists of two quarter circles and a line segment. So first of all, I've just worked out the area because we're going to use the area underneath this f graph is going to help us define the g function. So the area to the left in the big quarter circle is going to be radius 3 circles, so 9 pi, and it's only a quarter, so it's 9 pi over 4. We have a radius 1 circle part, so that's going to be pi, and it's going to be a quarter of that to the left. These triangles are 3 by 1.5, so it's going to be 4.5 divided by 2, or 2.25 is going to be those two areas. Okay, so just a reminder that when we define this function, it's being defined with an x part here, and then also the integral part here. And the integral part, it's important to remember that it starts at 0. So 0 represents our starting point. Going this way represents a positive displacement, and this way is negative. Okay, so we have to keep that in mind. So as I go to the right, above is positive, below is negative. If I go to the left, the opposite is true. Above is negative and below is positive. So part A asks to find g of -4 and g prime of -3. So let's start with g of -4. G of -4 is using the g function and plugging in -4 into that expression. Okay, so when I plug that in, I get -8 plus the area from 0 to -4 under the f graph. Okay, now because we're going from 0 to -4, I'm going to the left. So I'm going to use some algebra here to rearrange that expression. So first of all, I'm going to work out that's -8. And I'm going to flip the bounds. So I'm integrating left to right. Okay, and then I'm going to make that, whatever that area that I have above is the opposite sign. And it's going to be the area under the f of t graph. So when I calculate this value, it's -8 minus, okay, the area below is going to be -4 pi over 4. And the area above is going to be positive 9 pi over 4. Now, I've treated that as above is positive and below is negative because I have flipped the bounds. I'm just going to highlight this. I made that negative here by flipping the bounds here. Okay, so you could keep track of the positive and negatives other ways if you like, but that's the way I'm keeping track of my positive and negatives. So when I put this all together then, the g value at -4 is going to be -8, and this is going to be minus, it's going to be -1/4 minus from 9 over 4, so I get 8 over 4, so it becomes 2 pi. So it's going to be minus a positive 2 pi. Okay, so that's my y coordinate when g is and x is -4. The question also asks, find g prime at -3. Well, g prime, I need to first define g prime. It's the derivative of my g graph. So taking a look at my g graph, I need to differentiate the 2x first, and then the derivative of the integral. So firstly, differentiating the 2x, I get 2 plus, well, the derivative of the integral, I'm going to apply the fundamental theorem of calculus, and I'm just going to end up with f of x. So that expression represents my slope function, or g prime. So g prime then at -3 is going to be 2 plus the f value at -3. The f value at -3, when I take a look at it, looks like it's going to be 0. Okay, so that's going to be equal to 0. So it's going to be 2 plus 0, which is 2. So I have a slope of 2 at that point where the f graph crosses the x-axis. Is going to have, the g graph is going to have a slope of 0. Sorry, a slope of 2. Part B of this is asking, determine the coordinate of a point that of which g has an absolute maximum. Okay, so first of all, to find an absolute maximum, I need to find where the derivatives are equal to 0. So I need to look at my g graph, sorry, my g prime graph, and I need to make this function equal to 0. So when I do this, I get f of x is equal to 0. This is where I'm going to find my slope is equal to 0. So my f prime is not equal to 0, it's equal to negative 2. So looking at my f graph, so I have my f graph here that I can take a look at. And where f is negative 2, that's where I'm going to find my g value equal to 0. So that's going to be right at this point here. Okay, at that point here, my f graph is equal to negative 2. F equals to negative 2 is going to give me my g prime equal to 0. The x value when the f is negative 2 is going to be x looks like it's equal to 2.5. Okay, so when I look at my graph here, it's going to be at 2.5. So at x equals 2.5, I have a potential min or max point. And if I take a look at my f graph, that's the only point at which my graph is going to be equal to negative 2. So that's my only critical point that I need to check. So I'm checking for an absolute maximum. So what I need to do then is I need to make a table of values to check for g values and which g values are max. One of the points I have to consider is going to be x equals 2.5. I also have to consider endpoints, so negative 4 and positive 3. So these are my potential candidates for max points. Well, I've already worked out g of negative 4. That works out to be negative 8 minus 2 pi. I need to check for 2.5 and I need to check for 3. I'm also going to draw my slope chart here just to confirm whether it's a min or local min or max. So there's my g prime is 0, x is 2.5, and I can see on the left of 2.5 of that graph, my g prime is going to be positive, okay, because it's going to be these values in here above negative 2 is going to give me positive g prime, below is going to give me negative g prime values. So on the left there, I have negative values of my g prime. So that looks like it's going to be a local max. Okay, so I've tested one point. I need to work out my g values at x equals 2.5 and x equals 3. So at x equals 2.5, it's going to be 2 times 2.5. Just going to move that over a little bit. 2 times 2.5 plus the area underneath the curve from 0 to 2.5. And that's under the graph of f. So this works out to be equal to 5 plus, well, the area from 0 to 2.5 is going to be from 0 to 2.5. It looks like I have positive 2.25 is the green area. And then this area in here, that's going to be 1 times 2 divided by 2. So this area is going to be equal to 1. So or negative 1 in this case, since it's below the x-axis. So it's going to be plus 2.25 minus 1 or plus 1.25. and that's going to give me 6.25. Okay, so 6.25 then represents a local max. At this point, it's my absolute max, but I still need to consider G at 3. So this is going to be 2 times 3 plus the area under the curve from 0 to 3 under the F graph. So when I take a look at my F graph from 0 to 3, well, from 0 to 3, I can see that, I'm just going to erase some of this part here. I can see that I have from 0 to 1.5, I have 2.25 area above. From 1.5 to 3, I have the equivalent area below. That's going to cancel out, so the net area is 0. So then G of 3, G at x equals 3 is going to be 6 plus a net area of 0, or just 6. So in this case here, we can see that the absolute maximum then is going to be at the local max of 6.25.